Welcome to the third Spark Screencast. In this screencast, we will pick up where we left off in the first screencast. That is, in the Spark Quick Start Guide at the section on using RDD operations. And we'll work up through the section on caching, where we'll learn about storing RDDs in memory. First, let's navigate to the Quick Start Guide online. Start by visiting spark-project.org. Click on Documentation. Choose your version of Spark. I'll use 0.7.0, the most recent release. Then, under Programming Guides, choose Quick Start. For this screencast, I'm simply going to read through, starting at the section about RDD operations, copying and pasting the instructions provided as I go. Before we start, let's double check that we have our Spark shell ready to go. I assume that you've already downloaded and built Spark. If you haven't done that yet, go walk through the Spark screencast number 1 now, which is called First Steps with Spark. It takes you through the process of downloading and building Spark and familiarizes you with the Spark shell. On my machine, I built Spark inside my home directory /downloads/spark-0.7.0. I'll start the shell inside that directory with the command spark-shell. Remember from the first screencast that the shell sets up a variable called sc, which stands for Spark Context. We'll use that in our commands. Before we start walking through the section called More on RDD Operations in the Quick Start Guide, let's replay the commands from the previous section by copying and pasting them into the shell. This way we'll have the necessary variables set up for this section. Again, please watch the first screencast for a more detailed walkthrough of this part if you're unfamiliar. So under Basics, let's run the command that loads a text file, which is the Spark README, into the shell. And then we'll set up a variable called lines with Spark, which simply contains a filtered set of lines, only those that contain the word Spark. Excellent. Now, moving on to the section called More on RDD Operations. Let's get started. Recall from the last tutorial that RDDs support actions and transformations. Recall that actions return values, and transformations return pointers to new RDDs. RDD actions and transformations can be used for more complex computations. Let's say we want to find the line with the most words in our text file. I'll paste in the command that does this. It's 15. Now let's take a look at what this is doing. First, we use a map operation on our variable that represents our text file. We pass in a lambda. For each line in the text file, we split it according to the spaces, and then we return an integer value that is the size of the line. Then we provide a reduce operation which compares different lines, and for each time it does a comparison, it returns the longer of the two lines. Currently, the longest line in the README is 15 words long. The arguments to map and reduce are Scala function literals, or closures, and can use any language feature or Java or Scala library. For example, we can easily call functions declared elsewhere. We'll use math.max to make this code easier to understand. To do that, first let's import the java.lang.math library. Notice in this command, we've replaced the if statement with math.max. And we see the same result. Moving on, one common data flow pattern is MapReduce. which was popularized by Hadoop MapReduce. Spark implements MapReduce flows trivially. Let's do that now. Here, we combine the flat map, map, and reduce by key transformations to compute the per word counts in the file as an RDD of tuples of string and int. Notice that this returned an RDD because all of the things we did were transformations. To collect the word counts into our shell, we use the collect action. Remember, actions return values. Here we see the results of our word count MapReduce job, which is an array of tuples. Each tuple contains a token, such as a word, and a count of the number of occurrences of that token. Great, we've finished the More on RDD Operations section. Let's move on to the section in the Quick Start Guide about caching. Spark also supports pulling datasets into a cluster-wide in-memory cache. This is very useful when data is accessed repeatedly, such as when querying a small hot dataset or when running an iterative algorithm like Google's PageRank. As a simple example, let's mark our lines with Spark dataset to be cached in memory. The cache command is performed lazily, so when we call it on lines with Spark, our dataset is not actually cached in memory until we perform the next transformation or action. Let's do a count. Now, our lines with Spark variable has been cached in memory. If we call count once more, this operation is being performed against the in-memory dataset. It may seem silly to use Spark to explore a cached 30-line text file. The interesting part of this is that these same functions can be used on very large datasets, even when they are striped across tens, hundreds, or thousands of machines. To do this interactively, we need to connect Spark Shell to a cluster, which is described elsewhere in the documentation, and which we will do in a later screencast. That's it. You've now seen the basics for working with more advanced actions and transformations on RDDs, and caching datasets in memory with Spark. I'm signing off now. Enjoy Spark!